this is for year 11 methods. We're going to look at question 9 from exercise 2H. So John and Michael run a race over 15 meters. John runs it so that it takes A seconds to run 1 meter, and Michael runs so that it takes B seconds to run 1 meter. So what that information gives you is actually what the speed of John and Michael are respectively. So we know that John runs, well, we know that the speed formula is distance over time. So if John takes A seconds to run 1 meter, it means its distance, which is 1 meter, divided by the time it took, A. So 1 A meters per second. Now Michael takes B seconds to run 1 meter. So for 1 meter distance, it takes B seconds, meters per second. Now we know they run a total distance of 50 meters for the first race. So we know Michael wins a race by 1 second. So let's form an equation relating the time for both Michael and John. Now let's change the speed equation to make time to subject. So I can switch the S and the T. We get T equals D over S. So that's the expression for time. Now the time for John would be D over S. So D would be 50 meters because they both ran 50 meters divided by the speed. Our speed for John is 1 on A, so it's just 1 on A. And we want to compare this, so I'm going to put equal signs for now. We want to compare this to the time it took for Michael. Because Michael also ran 50 meters, so T equals D over S. And the speed for Michael is 1 over B. Now we know that overall, Michael wins the race by 1 second. So we know this part's Michael, this part's John. This is the time of Michael, this is the time of John. Now if Michael wins the race by 1 second, it means that I need to add 1 second here for them to be equal. So let's simplify this equation because we've got some fractions and we don't really want it 1 fractions. So to get this to be a nice equation, you can move the A at the top, so it's 50A equals 50B plus 1. So I've got my first equation. Now it says on the next day they race again over 50 meters, but Michael gives John a 3 meter head start so that John runs 47 meters. Okay, so again we're looking at comparing the times. So for John, instead of the distance being 50 meters, it's now 47 meters. So it's 47. So the expression for time, it's 47 on speed, which is he's traveling the same speed, but it's just running less distance. And for Michael, we know that he is still running 50 meters and his speed's still the same. Now, Michael wins a race by 0.1 second this time. So it's not 1 second, it's not 1 second anymore, it's 0.1 second. So in order for them to make this equal, we need to add 0.1 here. So again, I'm going to rearrange the equation. Well, change the equation to make it a nice equation to work with. 50b, so I've got to remove fractions, plus 0.1, plus 0.1. So there you go, I've got two equations, and I want to solve this simultaneously. So I've got 50a equals 50b plus 1, and 47a equals 50b plus 0.1. Now I can subtract equation 1 and 2. So 50 minus 47 is 3a equals 50b minus 50b is 0. 1 minus 0.1 is 0.9. So a equals 0.3. Now, I want to find the value of b, because that's what the question asked me. I want to find the value of a and b. So b would equal, so another way of putting that is, that's 3 over 10. Now b equals, I'll need to sub this in to equation. I'll sub into this one, and I get 50 times 3 over 10 equals 50b plus 1. That's 150 divided by 10, which is just 15, equals 50b plus 1. I subtract 1 from both sides, so I get 14 divided by 50. So b equals 14 divided by 50, or another way of saying it is 7 on 25. And there you go, we've got the value of b. Now it also asks you the speed at which Michael runs. So Michael runs at 1 on b. We know 1 on b is the same as 1 on 7 on 25. So we simply flip the fraction. So it's 25 on 7 meters per second. And that's how you do the question.